Hello and welcome to episode 5 of this mini barn build series. In the last video we took a break from the mini barn build in order to make the much needed improvements and modifications to this rebar bending tool. Today we're going to get this in use and get this steelwork in place.
In the previous video, where I was digging out the foundations, I did indicate that I wasn't sure yet whether it would be a timber retaining wall, as you see here, or concrete. However, I was able to find good solid ground, and that means I can build a concrete retaining wall, which not only will be a stronger structure, but also allow me to create this illusion of a lower story. And here is the structure I need to create. It's made up of 3 concrete pours: the slab, the wall, and the footing. So today my plan is to get the footings in place, which means working out where all of the steel reinforcement needs to be.
Now the first job is just to do a quick tidy up of the worksite, because as you can see here I have buried all of my rebar in the stone. All of this stone will go back in as drainage once I've sifted through it, but for now I just need it to be flatter as a safer working area. The final thing I need to do to this trench before I can go ahead and put the steel reinforcement in place is bury this piece of pipe here underneath the foundation. Later I can dig the 2 ends up and this will become a vessel for the gas pipe and the electrical supply to the tiny barn. Right, just going to send that in 50 millimeters, and so concrete can't fill up the other end. Now we'll also need a conduit to carry the data cable or the internet cable out to the tiny barn and then later on down into the workshop, but that needs to have a degree of separation between the electricity supply and of course the internet. They can interfere with each other, and so whilst I've got plenty of depth here in this trench behind the wall in order to bury the 2 and have a good separation between them, minimum of 300 millimeters but more if possible, where it actually runs into the cabin I don't have enough space in this trench here, and so I'm going to be putting the data on this side of the wall, and that just means digging another trench once the wall is built.
Well, that's enough preparation and talking about it. Let's get some steelwork measured up and prepared and into this trench so that we can get some concrete poured. Now we need a minimum of 75 millimeters cover between the steel and the edge of the concrete, and the bottom and the top of the concrete. Now I'm going to go slightly over that, just in case there's any undulation or bend in the bar. Currently we're sitting at about 100, and about 90 there, so that's good. The footing's really quite wide here at the front, so I'm using 4 of these rails, and they'll be connected to each other using stirrups. And here you can see how one of those stirrups extends into what will become the chimney breast area. Now that is also going to be providing a whole lot more strength to the retaining wall, acting as a buttress.
Hey, come back. Downsides of having a steep driveway. Okay, just measure these for length, and if I measure all of them I can get myself a little production line going. Save myself just a little bit of time. There we go, longer than it needs to be, but I'm not going to bother chopping it off, it'll just give more strength to the footing.
And here are those stirrups. They have a pigtail or hook on both ends, and they're designed to provide lateral support in the concrete and resist any chance of buckling in the steelwork. I'm working on a 200mm, that's 8-inch spacing for everything in the foundations here. And of course every joint has to be tied so that it doesn't move when the concrete is placed. Now, using this handheld wire tying device really is slow going, especially when there's so many joins in this particular structure. But I just can't justify the cost of a machine. But boy, would a machine be great right now.
So the only rebar tie wires that I could get were 400mm long, which is much longer than they need to be for this. So I'm being cheap and cutting them in half, and actually saving the installation time more than anything else, because there's a far less twisting to do. And the centers of these, they're roughly 200mm, 8 inches. They don't need to be perfect. I am measuring them just so I don't get an accumulation of error across this grid. But within 5mm, 1/4 of an inch, I'm happy. So that I can make sure that the vertical rebar is in exactly the right position in relation to the wall, I need to re-establish where the front of that retaining wall is. And I need to do this with some accuracy. Now, if I'd still got the batterboards in place, I could have pulled a string line between them and then projected down to the trench in order to determine exactly where the front of the wall is. But I don't. So instead, I've set up the laser. I've got it set up on the corner of the tiny barn floor, and it's perfectly parallel with that front edge. And this detector is going to be locating the laser. Eventually, there it is, and it's telling me I need to keep coming this way, and I'll just get that perfectly lined up. There it is. So now this detector is perfectly in line with that laser. Spray paint a line across here, and then do exactly the same at various locations through the trench, and that will show me exactly where my verticals need to be in relation to the wall. Now, it doesn't matter if this is a little bit off. The positioning of the rebar just needs to be inside the wall with a minimum cover of concrete, 75mm at the back against soil, 50mm at the front. And I'm going to be well within those boundaries. And there we have it. That is where the front of the wall is going to be. Nice. Now, one of the really good features of this laser level is the self-leveling head. Speaks for itself when it's on a tripod, and it's then going to level itself to give you a perfectly level laser. But I can also override that feature with the remote control, and I can cause the laser to tip so that I can project a slope. Now, that's really beneficial here when the laser's on its side, because I've got the laser perfectly on my mark, 7.5 meters from the other side of the tiny barn, and I don't know where it's projecting up at that end of the building. I need this to be a 90-degree square corner. So I'm right on the corner of the building here. I've got it projected onto the mark. I can go to the other end, position my detector at the 7.5 meter mark, and then using the remote control, I can alter the angle of that head until it comes back into alignment with this detector. And that way, I know it's perfectly 90 degrees. Now that I'm happy with. Okay, let's mark it out. I usually don't use a lot of paint, but as I told you in the last video, I don't particularly like this white, and so I'm quite happy if it gets used up quickly. Right, that's the outside of the wall. And this is going to have a skin of clay brick and then the concrete wall itself.
Then I have to think about going to get some more rebar from the supplier.
Because, well, I'm all out. Now, which way around does this go? Okay. That's the way. Just like so. Right, extend those two centerpieces up through this step and straight out to here. And then I can make these two tracks.
But first, a trip out to the supplier and add another 20 lengths of rebar to the mix. Now, I am working to a drawing here. I've measured up the depth of steps and the length of all the runs, and I'm trying to be as efficient as I can with the material whilst keeping it as long as possible to minimise the joins.
I'm looking at 900 to the corner, and 515, 1300. So add all that together, 2.7 metres. So pigtail plus 2.7. And these are 6 metre lengths, so if I cut one in half, that'll give me my two pieces. Nice. Right.
So knowing that this 3 metre length will get me along the horizontal, down the step and along the next trench, all I need to do is start at one end, making the pigtail, then I can check the drawing to see how long this run needs to be.
Step height of 515. And the way I've figured this out is that if I measure from here to my step height, if I use that as my tangent point on the roller, it'll actually bend out to here, and it'll be 30 millimeters too big. So I come back 30 millimeters, and that's my tangent point.
So make sure that the mark lines up with the tangent on the roller, that the leg is perfectly vertical, and then pull it to 90 degrees. In this way I end up with a piece of rebar that runs along the profile of the step without any joins, maximising its strength. Now I found that I could cut 4 or 5 of these rebar ties at once, and then bending them in half really quickly gave me 8 to 10 loops ready to tie off.
Now if you've got two rebars joining together, rather like we have in this situation, you want to make sure that there's a nice tight join between the two. If there's a small space like we've got going on here, concrete can't get in there, and so you'll have a void. A void is a weakness, so make sure you put enough ties on to pull the parts parallel and tight to each other. And you can see it's nice and tight here. If it wasn't, I'd put a couple of more ties in there. I have made a small error here, just one too many of these ladder frames, so I'm going to swap this out for this longer piece that will take me right up to the step.
Well, this E500 rebar really is quite tough. It's difficult to cut and it's difficult to bend. It's really strong. Now that's got to be a good thing when it's installed in the wall.
Wouldn't it be funny if I'd cut all of these the wrong length? That would be absolutely hilarious if it weren't true that I have actually cut them all the wrong length. You see, when you work out how long you want to cut this rebar to length, you're supposed to add 300 millimeters to account for the two pigtails, and I only added 200. So they're all 100 millimeters too short. I'm hoping I can still use these elsewhere on the wall where I need shorter ladders, but for now I'm going to have to recut all of these and make them again.
Well, that didn't take long to make a whole nother set, and I was able to use those shorter ones over on the other side of the wall nearest to the tiny barn structure.
Right, now just these last few ladder rails to put in place, and then I can get some of the verticals in. So I've taken the time here just to outline where the back of the wall will be, and that way when I come to put my verticals in, there's no thinking involved in terms of where they need to be, in the middle of those two lines. And while I'm in the trench, I'm going to take the opportunity to put a mark across the wall of the trench through here, and that mark is going to determine where the top of the foundation is going to be poured to. It's going to make it much easier when I pump the concrete in here to be able to bring it up to that line, to that mark, and then I know it's nice and level. Now we're going for a 300mm foundation footing here. That's a foot. So pop a mark on there. Get it level. And just put some witness marks across the dirt. And this way, when I pour the concrete, I'll know it's nice and level without having to get into the trench to double check. Now before I go ahead and install the vertical rebar, I'm going to be lifting this mesh that I've created up onto these chairs. Now these are a plastic chair designed to raise the reinforcement off the bottom of the trench by the correct amount. To code, this has to be a minimum of 75mm, 3 inches. These are going to raise it by 90mm, so slightly more concrete underneath the steel, and that's got to be a good thing. Now there has to be a trick on how to install these underneath the mesh when it's all tied together and you're standing on it. But I don't know that trick. And so let's see how I get on. I may have to work from the side here and lean over into the trench. There's a lot to install, so let's get started. Now I talked about how to install these in greater detail in the previous retaining wall videos that I've did. I'll put a link in the description below.
Who knew I'd have to build another retaining wall quite so soon after the last one?
This gets tricky. Well, I think I found the trick. Putting your body weight onto the mesh that you've already raised up on chairs allows you then to lean forward and put chairs on the mesh in front of you. I mean, it's still not easy, but it's achievable. That's enough, it's well supported. A bit random, aren't they? Now, I've spent 4 or 5 hours on the computer here just finalising the details for this retaining wall, and I need to do that so I can make sure when I'm pouring the footings I'm putting the steel reinforcement in the right place. Check this out. So the purpose of spending so long on here just working out the design is to basically rehearse the build. It's not something I've done before, and so I want to be able to go through the stages step by step to see how achievable it will be, what it will look like, and what problems might arise that I hadn't considered. Modelling it on computer allows me to do that. The tweaks and adjustments I've made to the design are so that it ends up being a really well tied together structure, so all the steelwork works together, and perhaps as important, it's manufacturable. I can do it with the skills and processes that I've got. All too often, you can design something on a computer or on a piece of paper that looks great, but in reality, it's just too difficult or even impossible to build. And so I've spent the time to make the adjustments to this design so I know I can build it and I know it will be strong. So here's what I'm trying to achieve in the first pour. You can see the steel reinforcement bars poking out through the footings, and it's the footings that I'm attempting to get sorted now. Once I know all that rebar is in the correct place, and this helps me figure out where that correct place is, I can then set up the formwork and do something which I've never done before, and that's pour a concrete wall. And that should look like this. Right, well, there's our steel reinforcement, minus the horizontals. Let's go and get it in place. So a new day, and I'm hopeful that today I can get all of the vertical steels in place. So the only thing left to do before concrete is to shutter up the edges of all of these steps in the foundation. Then we can get the concrete poured. But before I do any of that, I was looking out of the window this morning and I'm not very happy with something I've done. Now, I've positioned all of these chairs where the mesh felt like it needed support. And then when you step back and look at it, it looks shockingly bad. I can't deal with the fact that all of these chairs are just haphazardly placed. Now, I know they're going to get buried in concrete. You'll never see them. And I'm completely wasting my time in repositioning them. But you know, I'm going to do it anyway. So I've got these spares. Let's just reorganize a few of these. It'll take 5 minutes and I'll be much happier for it, despite the rain. Well, there we go. I'm much happier with that. Equally spaced. What's not to be happy about? Now, regardless of the length of these vertical pieces of rebar, the amount that's actually sticking into the footing of the foundations is going to be the same length. And so the bend needs to be in the same position on every single piece. So it's worthwhile just taking a moment, and it literally is a moment, to take a scrap piece of material, measure out the length that we need, and then each one I need to bend, I can bring up to the piece of wood, make a mark, and then I can line this up with the roller, make the bend, and that way I know the length is exactly the right distance and it's the same on every one. Really nice, quick and simple template to make, and important because I've got 90 of these to do.
That's all the vertical rebars in place. Now I'm just going to tie them up to a horizontal bar just to support them and keep them in the right position as the concrete footing goes in. Then adding the safety end cap so I don't poke my eyes out while I'm working on this, and then repeat the process for the remaining part of the wall.
1.8. Get a piece, bend it at 1.8. And try and line it up with where the corner needs to be. Then I can get these ones vertical. It'll be much easier then to install the remainder. Well, that's the plan anyway. I've just got these final few pieces now of vertical rebar to put in place in this area, which has got extra reinforcement because it's the edge of the tiny barn structure. And so I've double checked my measurements, and it's always worth double checking your measurements because I have made a mistake. There's an error here. And when I did my initial rough out for this trench, I positioned the post, or rather the corner of the tiny barn building, right here where you see these two marks. And I've dug out my trench and I've put my steel reinforcement in place to suit that. I've just come to check the measurement so I can get these verticals in exactly the right place. And it seems I'm 10 inches out, 250 millimeters. So this is the area that should have the reinforcement for the post, and this, well, isn't. Now, it's not the end of the world, although it will slow me down a little bit. Now is the time to find this problem, not after I've poured the concrete footing, or indeed after I've poured the wall itself. All I have to do is chop out some more of this soil, tiny bit more digging, relocate this reinforcement bar that you see over here where it extends into this little alcove. I'm going to chop that out, pull it over 10 inches, and we'll be good to continue. Always double check. Ooh, that's a problem. The chairs are in the way. I'm going to have to lift the chairs as well. Oh my goodness. This job just gets bigger. But not insurmountable.
And really didn't take all that long. So here we go, the steel has been relocated, and I've just got a few final pieces to put in before we're ready to put the shutters in to support the concrete for the stepped locations in the foundation. Now there are 5 steps in this foundation, and each one needs to have a shutter built and installed so that the concrete can be retained. I'm using these old fence palings to make up the shutters, joining them together to create a board the correct measurements for each of the steps, because they're all slightly different widths and of course slightly different heights. Now the steps are quite deep in places, and so the shuttering has to be supported and installed in a way that it can withstand the weight and the force of the concrete. Because the last thing you want when that concrete gets poured in is for the shutter to blow out and all the concrete end up exactly where you don't want it. So I'll spend some time just chipping away at the rock, creating a groove for the shutter to sit into, but it still won't be strong enough. So I'm probably going to have to add some timber bracing. Perfect.
Right, well that's it wedged in, but there's no way that that's going to hold back the weight of all of that concrete. So I need a plan. Now ordinarily I'd put a spike in the ground here to support it. I can't, it's rock. Or I'd put a spike in the side here and here to stop it falling forwards. And I can't because it's rock, so...
I'm going to have to use some timber for bracing, just as you see here.
Now you can see how far out we are, so I need to push the bottom of this shutter this way. So I need to pull this in this direction, which I just can't do, it's too strong. So I've got this spade down the back, and if I use it as a lever, I should be able to put enough pressure on there to get it level, like that. So I'll put lots of pressure on, put the screw in, release the pressure, and check for plumb. And that's too far. So release it a little. And that screw's just spinning now, so pop a new one in here. Check it again.
Perfect.
Well, now I'm ready to order the concrete to get this foundation finished off, and I need to take some measurements to be absolutely certain that I order the correct amount of ready mix. So I've decided the simplest way to do this is to split this foundation up into a variety of rectangles, measure each rectangle, length, width, and of course depth, and then add the lot together. And that should give me a fairly accurate number on how much concrete I need to order. And so here I'm going to have 800 by 950. Pop that on my plan here. 800 by 950. And of course the depth of that footing is going to be 300. Now crucially, you want to make sure to also measure the steps, because the concrete that's going to go down behind the shuttering also needs to be accommodated. So now I've got the measurements of each of those rectangles, I can go ahead and work out how many cubic meters each of these components would be, add the lot together, and that will tell me how many cubic meters of concrete I need to order. So for example, this first one is 1000 millimeters by 600 millimeters. It's 300 millimeters thick. Remember, we're working in cubic meters, so 1 meter multiplied by 0.6 multiplied by 0.3 for the thickness gives me, let's put this down here, 0.18 meters cubed for this rectangle here.
Then just repeat for all of these areas.
And I'll go ahead and add all of those together, and that will tell me just how much concrete we actually need. And we'll add on the steps. Now this is, I've done this separately just so that we can see how much concrete would we be short if we'd forgotten to measure the steps up. A third of a cube. Add those two together, 3.93. I'll order 4 cube. Well, that's the concrete truck booked, and the pumping truck that's going to help me get the concrete into the hole without spilling it all over the place.
Now, as you can see, the pump truck can get really close to the area that the concrete needs placing. And maybe with enough bodies and wheelbarrows, I could have taken it straight from the chute of the mixer and put it down and placed it into the foundation area. However, it is quite a distance to pour it vertically. So instead, a nice, controlled and stress-free pour.
Isn't that a beautiful thing, mate? Not even messing my hand. You gotta make that vibrating noise when you do that. I am inside.
I'm choosing to use a tamper here to level out the concrete. Now, it's actually a rake with a piece of plywood screwed to the end. Now, the reason I'm not using a vibro tool here is because it will most certainly cause all of the concrete to settle to the bottom of those steps and run through to the next level. I actually need it to fill up these steps, and so tamping it gently allows me to get it level. But once I get away from the step areas and into the large flat surfaces, that vibro tool does a magnificent job of leveling out that concrete and removing any air bubbles to ensure that we get a really strong footing. So it's a very useful tool to use where it's appropriate. Especially here, where it's actually quite wide. I can't reach with the rake to the back edge of the footing, and I don't want to get in there. So this is just a footing, it'll never be seen. It doesn't need to be particularly smooth, but it does need to be flat, and it doesn't want to have any high spots which will get in the way of my shuttering when I come to build the formwork for the wall.
See, mate?
Cheers for that. Thanks a lot. Cheers, guys. Absolutely. Hey, Steve, you want YouTube?
And then, just as it was going so well, disaster struck.
Let me cast your mind back to earlier this year when I built this retaining wall. And if you've watched that video and in particular read the comments, you know that we had quite the debate about whether the top edge of this brick should be curved or left square like this. And overwhelmingly, thousands and thousands of you decided that that should be remaining square-edged as it is at the moment. And only 2, possibly 3 people out of the thousands who gave their comments said it should be rounded. Well, this morning it would appear that our pump truck driver has made the decision for us. Take a look at this. So how does it feel to be the guy who's decided on whether that top of the wall should be sharp or rounded?
I'm quite happy actually because you made a good decision, I think.
You reckon? So how heavy is your truck that hit the wall?
About 10 tonne.
10 tonne. 10 tonne and the wall's still standing. So oddly enough, I'm still happy about that.
I don't know how I feel about it, but it's okay.
Oh well, never mind. I think I'll just take the grinder on that and polish it up.
Sweet as.
Now actually, it could have been a whole lot worse than it actually is. It is just these 3 bricks that have got their front corners or top corners knocked off and a little bit of damage down here and a bit of scraping. But to be honest, I'm not overly concerned by that. You know, these are old reclaimed bricks, and many of them have got chips and scours and the scars of life showing in them, and I quite like that. And this is just another piece of the history of these bricks and a new piece of history for this wall. And honestly, I don't think this will be the last time it has contact with a vehicle. Now, do remind me, why did I ever pour my own concrete? You know, mixing concrete is back-breaking work, and it takes a long time. 30 minutes of pumping and, well, all that concrete is in the hole. It's level and it's starting to go off. Just need to get cleaned up now, clean up all the tools, and then as it's starting to go off, I can start to cut in the groove, which is going to accept the retaining wall. Now, this was the first part of the concrete that we poured or pumped, and you can see it's still really quite wet. It's less than an hour it's been in the ground. I'm going to keep coming back and checking on this, and when it's much more able to hold its own shape, I'm going to come back and cut a channel through where the rebar is, and that will give me a keyway to lock in the retaining wall. Now, this is a little trick I saw recently on the Perkins Building Brothers channel, and what they had was a guy taking out a little slither of concrete around the reinforcement bar, and the purpose of this is to provide a keyway, so that when the poured concrete wall goes in above it, it's got something to lock its base in place. So I'm just going to take out the bulk of that. Now, of course, this concrete footing will have gone off way before I pour the concrete for the wall itself. And so you'll have a cold joint between the two. And so, really, what's the only thing that's holding the wall to the footing is the steel reinforcement bar. Now, that's sufficient, but there's a lot of force potentially against this wall. And if you can find a way of strengthening that bond between the two, why not do it? I really don't want to waste this concrete, and so I've got this mould I've made up, and this is for a new cover for the septic system. If I can retrieve enough concrete to make myself a new cover, I'm absolutely going to.
Making sure to put some steel reinforcement in there, I was able to reuse all of this, what would have been wasted concrete. And a little later that day, cracked it out of the mould, and I think it turned out really quite well.
Now, these shutters could have been removed the very next day after the pour, but I've been busy.
I've had some TCB to do.
TCB, you know, taking care of business. And so it's been a little over a week. However, the benefit there is that the concrete will have dried thoroughly, and so would the timber for the shuttering. Now, that timber will have swollen up when the concrete went in, and of course now it's dry, it'll have shrunk back down, and in theory, we'll see, should be easier to remove. It's not. Nice. So I'll just finish removing these last pieces of horizontal bracing, and then I can sweep up the foundation and get ready to lay out for the boxing for the wall. So that's the foundation completed for the retaining wall of this tiny barn. Not my very best concreting finish, I have to be honest. It's level, it could be a little smoother, but that's okay, I'll deal with that when I'm doing the boxing for the retaining wall. And that's what we'll be doing in the next episode, putting the boxing in place and pouring the retaining wall. Can't wait to do that, haven't done it before, really looking forward to what could possibly go wrong. So until next time, thanks so much for watching, bye.